Welcome to the channel Professor Davinci. Today's topic is angle in a semicircle. Angle in a semicircle. Let me draw a circle. Assume that this is a circle, right? Here, let me draw a line. So, I have drawn a circle. This is the diameter. So, this is the point A, point A, point B. Assume this is the center of the circle. It's a O. Somewhere P in the circumference. I draw the line. Okay, right. Consider 3 points A, B, and P on the circumference of a circle. Right? AB is the diameter. So here you can say AB is the diameter. Okay, as shown in the diagram. The center is already said center is O. Now AOP and BOP, the triangle, say the triangle AOP and BOP or isosceles triangle. Isosceles triangle. Say for short I can write triangle. What is isosceles triangle? Isosceles triangle meaning the two sides, if a triangle, I just write definition of iso. What is isosceles triangle? If the two sides are equivalent, so here the triangle AOB and the BOP are isosceles triangle. What is isosceles triangle? If the two sides of a triangle are equal, then we can say the triangle is isosceles. Take the triangle AOP. Here, this side AO and OP are of same length. How? Because AO and OP are the radius of the circle. So this is center point, right? And also here OB and OP are also same length because OB and OP also a radius. So the triangle AOP and the BOP are isosceles triangle. Got it? Now the angle. Now the angle between AOP and the angle OPA in the triangle AOP are the same each other. Sorry, angle OAP and OPA are same length. Not same length, same value x. Okay, and also the angle OPB, and OBP are of same value, say y. And what is the angle of APB? Therefore, angle APB equals, say, x plus y. Obviously, the angle of P, you can, in short, I can say the angle of P is x plus y. Okay, right? The sum of interior angles. So this is the, so if you take a very large triangle, say AB, if you take the triangle APB triangle. In this triangle, sum of angles. Sum of angles equals, this one is angle of A is X, angle of B is X plus Y, angle of B is another Y. We can say that 2 times of X plus 2 times of Y. Also we can say, take it to a common, X plus Y. Got it? So the internal angle of the triangle APB is 2x and 2 times of x plus y. And also we know that the sum of angle in the triangle equals 180 degree. Putting that in this equation, 2x plus 2y, sorry, 2 times of x and y, 2 times of 2 times of x and y equals 180 degree. Already we know because we have studied the sum of any angles in a triangle is 180 degree. Already we know that. There is a rule. Okay. Now equating this one, 2 times of x plus y equals 180 degree. Then x plus y alone we can say it is 90 degree. Okay. Putting that, keeping this in mind, any triangle, the angle of P is 90 degree. Summarize this one. Therefore, any triangle drawn in a circle with the 2 points on a diameter and the third point somewhere on the circumference will be a right angle triangle. Very simple. If I draw a triangle, keeping one side of the triangle in the diameter and the another third point anywhere in the circumference produces the angle of that point is 90 degree, that is right angle triangle. Very simple. Since the diameter divides a circle into two halves, obviously always the diameter cuts the circle into two halves, that is two semicircles. A diameter is a line of symmetry. This is line of symmetry of the circle. So this also result in a fact often stated: the angle in a semicircle is a right angle. Okay. So from this point, what we infer, what we conclude, the angle in a semicircle in a semicircle is a right angle. So we can conclude the angle in a semicircle always a right angle. Okay. Now, one more thing. Additional information. Given 3 points, suppose if you are given with the 3 points, okay, on a circle, there are two ways to solving that. They are vertices of the right angle triangle. If 3 points is given, there are two ways to prove that they are vertices on the right angle triangle. Okay, that means what? If you want to find, there are two ways are there to find the triangle. This triangle is a right angle triangle. The first way is to show three sides of the triangle satisfy the Pythagoras theorem. Very simple. What Pythagoras theorem says, if you have a right angle triangle, then the hypothesis square, suppose this is a hypothesis, say x square, say this is a y or a z, okay, x square equals y square plus z square. This is the Pythagoras theorem. The square of hypothesis equals the square of two sides. One way is to show that the triangle is satisfies the Pythagoras theorem. The second way is to show that the two lines, that the two gradients of the sides satisfy the perpendicular. So for example, in this case, the line AP is perpendicular to AB. So one way to prove that the triangle is a right angle, one way by Pythagoras theorem, or ignoring the diameter. If you take the other two sides, we must prove that the two sides are perpendicular to each other using the gradient. What is the gradient? Gradient of line 1 and line 2 equals -1. Already we have seen this one, perpendicular line. With these two tests, we can say that the triangle forms in the semicircle, which is right angle triangle. Okay, right? Clear? Understood? Now, keep this in mind. Next video, we will go for a example problem. Okay? Now, repeating the same again. This topic is angle in a semicircle. If I take a circle and I draw a diameter, AB is the diameter, and if I take any point on the circumferences, that point is P. Now join 3 points A, P, B. Okay, you will end up in forming a triangle, and O is the center of the circle. So draw a line from O to P. Now you will have two semicircles, two triangles, number 1 and number 2. Both the triangles are isosceles triangle. What is isosceles triangle? In a triangle, if two sides are equal, then you can say the triangles are isosceles. The triangle 1, what is the two sides? OA and OP are same length, because O is the radius, O is the center point, and OP is the radius, as well as similarly OA also is the radius. So triangle 1 is isosceles. Similarly, triangle 2 also isosceles. If the triangle forms two isosceles triangle, okay, this is a now the angle between OAP is x. Okay, angle in isosceles triangle, the rule says that, the theorem says that angle of OAP and OPA are same, as per the theorem of isosceles triangle. Similarly, if we take a triangle 2, the angle of OPB and the angle of OBP is same. Let us take y. Okay. Now, here already we know that the sum of angles in the triangle is 180 degree. So, if we consider both the triangle 1 and 2, the big triangle APB, what are the angles inside? X is in x, the angle x plus y plus y, that is 2 terms of x plus y, equals 180 degree, and what is x plus y is 90 degree. From this we can say that the angle in a semicircle is a right angle triangle only. Right angle, the angle in a semicircle always right angle, that is the angle, the point B, the angle of point B always 90 degree. If you are given a 3 points in a circle, you want to check that 3 points are the angles of the semicircle, forms the angles of semicircle. Two tests we can do. First test, if those 3 sides satisfy the Pythagoras theorem, we can say that the angle is a angle in a semicircle. Otherwise, if you prove that two sides of this circle is perpendicular to each other using the gradient, meaning gradient gradient of a first line and the gradient of second line equals -1. If this condition satisfied, m1 into m2 equals -1, then we can say the two lines, the circle forms here. They say the triangle is a right angle triangle and the angle in a semicircle is 90 degree. Okay, so two lines. What are the two lines? Always I refer two lines is these two lines. That is AP and a BP. AB always the diameter. Excluding the diameter, other two sides. If you find the gradient of that two sides, it must, if it produces -1, then we can say the triangle formed by the 3 points is a right angle. If the triangle is a right angle, then we can say it is a angle in a semicircle. Clear? Understand? See you guys. Have a great day.